morning, everyone, and welcome to the RATAView 1.4 Wrapped Up webinar. I'm Taylor Hempel, and I'm a marketing specialist here at ESC Spectrum. Today, our senior software engineer, Andrew Hatcher, will share with you the new features and enhancements in the RATAView 1.4 software release. Just a reminder to hold any questions you have until the end and type them in the question panel on the right-hand side of your screen. After the presentation is over, I will read out the questions to Andrew, and he will answer them to the best of his ability. With that being said, Andrew, let's go ahead and begin.
Thank you. Good morning. I'm Andrew Hatcher. I'm one of the software engineers here at ESC Spectrum, and today we're going to be talking about RATAView. I'm going to start by talking about the product itself, go over what changes we've made for 1.4, and then we'll do a demo of the product itself. So, why did we develop RATAView? It came about because one of our DOS customers reached out to us and requested that we build some software for stack testing. We also used to have an in-house stack testing department that was using some very old software that didn't work with modern hardware, and we needed a replacement. And we kind of come up with six main goals when developing the software. First is to control the I/O. Software should be responsible for starting and stopping any sequences to control the flow of cal gas. The second was to collect data, because what good is software if it doesn't pull in data? The third is to guide the user or the tester, meaning we wanted to make a product that's easy to use, and we also prevent the user from doing something that they shouldn't be doing. For instance, we wouldn't want to allow someone to attempt to do a bias and drift check prior to doing a cal error. Next was to store the results. All calibration data, run data, be stored in the database for retrieval at any time. Perform calculations, because some calculations need to be seen while a test is underway. For instance, you might want to see a real-time NOx pounds per million BTU calculation while performing a test, and RATAView needs to be able to display that information to you. Finally, reporting. This should be obvious because you'll need to report the results of the test. This software is designed specifically for stack testing. And as I mentioned earlier, we used to have an in-house testing department, and we worked closely with them to develop RATAView. A little bit about the product itself. It helps stack testers perform RATAs. We tried to make this as automated as we could. The idea is that you can configure a test and then just let it go. And as I mentioned earlier, it's built specifically for RATA tests. It's a subscription-based product that's packaged with an 8864. We do provide a spreadsheet that retrieves data from the database. It comes with some reports already written, but you can customize it if you wish. As with all of our products, it has 24/7 support, and it's an actively developed product that's built off of our Prism DOS software. So it's not something that we're just going to sell and then forget about it. So what is RATAView? It's a Windows server and an 8864 data controller, basically. On the server, we run two Prism services to collect the data from the 8864 and to display any real-time data on the RATAView application. The database itself is a SQL Server Express, and it also runs on the server. The database is configured by one of our system implementation engineers. The RATAView application itself can also run on the server or on a laptop. The application is what the end user interacts with to perform the test. And finally, we provide a Microsoft Excel spreadsheet to retrieve the data. So what does RATAView do? Well, it simplifies regulatory compliance. The application allows for automated RATA testing and provides certain troubleshooting features. And the spreadsheet allows for faster reporting time. We can talk a little bit about the control flow. So how does the data flow in RATAView? All of the I/O points come from the analyzers and are wired in, or they can communicate via Modbus to the 8864. The RATAView server talks to the 8864, It collects 10-second averages from the 8864 and stores those averages in the database, and it displays real-time data to the application. It also tells the 8864 when to start or stop sequences. The client itself can be run on a laptop or the server, but it only communicates with the services and the database on the server. And all the data is stored to the SQL Server Express database that's located on the server. The client itself, there's 4 areas of functionality. The first part is a configuration page that allows you to add or retire bottles, view I/O, change certain instrument settings, and so on. The second part is building a test by either creating a queue from scratch or using a previous test as a template of sorts. And the third part is running a test. You'll see real-time results while the test is being performed. There's also a manual or automatic mode and different views, but we'll get into that later during the demo. And finally, the reporting is handled by the Excel spreadsheet. The spreadsheet connects to the database and pulls data from the test into the spreadsheet. And you also have the ability to have that update real time. Some of the advantages of RATAView are that you can configure a test and then automate the entire process. Any previously run test can be reused as a template for another test in the future. You can clear out the results of a particular QA event or run and restart any QA events or runs. The application allows you to pause a test and resume it later. And while we do enforce certain rules, for instance, you can't do a bias and drift check prior to doing a cal error, the expectation is that someone familiar with stack testing will be using the product. Some of our design concerns when building the software: we tried to make it as stable as possible, because the last thing anyone wants is for the software to crash while you're in the middle of a test. It must be able to pause and resume a test at any time. It needs to allow the user to reset QA events and allow the user to restart those steps. Each step of the database is saved to, or each step of the test is saved to the database for retrieval at any time. And as I mentioned earlier, the application won't let you do things out of order. The example I used earlier is a cal error must be done before a bias and drift. And although we do recommend an 8864, RATAView will also work with other I/O devices as well. And here's a screenshot of an example spreadsheet. There's a test tab where you would enter in the test ID and information about who is performing the test, whether the spreadsheet should automatically pull data from the database, etc. And you may notice there's a few green tabs. These tabs are responsible for pulling the data from the database, and they should not be modified, but all of the other tabs are customizable. And they display the information in a more user-friendly manner. But again, they're customizable, user editable. A little bit more about reporting. We do provide you with a spreadsheet that connects to the RATAView database. And as I've already mentioned, the data is pulled from the database, which should save you time because you don't have to hand enter data. And once the data is pulled into the database and you're satisfied with the report, you can save it off. RATAView does give you some ability to troubleshoot and resolve problems. All of the I/O points are displayed on a single tab. The analog points display the current value and the milliamps, as well as the scaling of the point. Digital points show whether the point is on or off. And from this tab, you can change the scaling of analog points and toggle digital points on or off. So what's new in version 1.4? We added the ability to move entire runs or QA events up or down. Previously, you could only move a single step of a QA sequence up or down, but there are some limitations to this. For instance, a bias and drift check can't be moved ahead of a cal error, or a bias and drift check can't be moved ahead of or after another bias and drift check, and a run can't be moved ahead of another run. We also added the ability to reset entire QA sequences. Previously, you could only reset a single step of a QA sequence. Now you can reset every step of that sequence with a single click. We added a response time QA class, and it's important to note that this does not calculate a response time, but rather it allows you to do a zero mid-zero sequence. And finally, we added support for the NOx converter efficiency bag procedure. That was a request from a couple of our customers. And that's it for the slideshow. Now I'm just going to do a demo of the product. So this is the, excuse me, this is the page you'll see when you first start up the application. And I'm going to be running this on our THIMS training system here, so you'll see some points that don't necessarily correspond with a real testing trailer. So just keep that in mind. But when you start up the application, any previous tests that you've run will show up in a data grid here in the middle. See the test ID, whatever name you've given it, when you started and ended it, any instruments that you used for it, and any optional reporting notes. And you can also continue any tests that haven't been stopped. Yeah. And you'll notice we have a configuration page, and we'll start with that. So the first thing you see when you go to the configuration page is a bottle manager. And this is where you'll add, edit, and retire any CalGas bottles. We have an active bottle inventory and an inactive bottle inventory. And it's important to note that the inactive bottle inventory is not retired bottles. We realize that you can have dozens of bottles in inventory, and sometimes you may only want to see the bottles that you're going to use for a test when you configure a test. So by dragging a bottle into the inactive inventory, that bottle will not show up when you're trying to configure a test. It just makes it a little easier to navigate. So you can move them in and out of active and inactive. When you click on a bottle, you can see its details over here on the right-hand pane. To add a bottle, just click the Add button, and you'll see a little wizard here where you give it a description, put in a vendor ID, a serial number, an expiration date. And then you go next, and you can add any constituents to the bottle. So if we had a bottle with NO 55 ppm, add that, and any more constituents. We had SO2 or CO2 also in the bottle, you could add that as well as a balance. And once you're satisfied, just click Finish, and that'll add the bottle into inventory. If you have a barcode scanner, however, you can just click Scan. You can scan the barcode on the certificate of analysis, and it'll fill in all of that information for you. It'll bring up this wizard with all the information filled in. The only thing you have to do is give it a description. Moving on to the Tags tab. Again, this is a SIM system, so there's a lot more tags than you would see in a typical test trailer. But this is primarily used by our implementation engineers when configuring a system. But this is also where you'd go to configure any calibrations that you might want to view. The example I used earlier was NOx pounds per million BTU. I think we have one here. So you can click on this and see what goes into it. And once we get to the test running page, we'll show you how this is used. But this is where you go to add and edit tags. Instruments. These are all configured by the engineer who's going to set up your database, but you do have some limited editing ability here as well. So if we wanted to edit this NOx instrument, just click on it, go to Edit. You can change the name or the description, the gas type. I wouldn't really recommend changing that unless you know what you're doing. The I/O channel is here to be is available to be edited in the event that something goes wrong with some analog input and you need to move it to another channel. So that's where you can go to do that. You can enter in a span value for the instrument, although it's really only used for VOC instruments. You can change the QA method. Right now we just call it EPA for normal, and then we have a CARB method for it's the California Air Resources Board. And we have an optional side. So if you have an A side and a B side, you can distinguish which side it's on by filling in that. And there's a checkbox here to tell us whether it's a dilution instrument or extractive. The sources tab, most of you would probably only see a single 8864 source, but this is where it's configured. You go here to see the IP address, the port number, and any other behind the scenes stuff, any the firmware version being used by the 8864. You can view any raw points associated with this 8864. You have analog inputs, outputs, and digital inputs and outputs. And again, most of this is used by the engineer who will be setting up the system, but it's there if you want to look around. For those of you familiar with an 8864, there's a similar page here that allows for point configuration. Looks almost identical to the other page, but this is what you use to configure channels in the 8864. And if you've ever looked at a server.cfg file, you can edit that here as well. And in the event that you ever need to cold start your logger, you can do that with a single click. I'm not going to cold start our logger, but that's where you would go to do it. We also have a raw points tab here, and this is kind of what I mentioned earlier in the slideshow. So this will display all the sources. And again, you'll probably only have a single 8864. And it probably won't have as many points as this one does. But for the analogs, you can see which channel it's on, the name of the tag associated with the I/O points, a real-time reading, the milliamps. The scaling is over here in this little gauge. So CO2, for instance, is scaled 0 to 20. If you need to change the scaling, you can just right-click somewhere in here. You go to Edit Scaling, and then we could change the scale high and scale low. And if we scroll down some, we can see the digital points. If you have inputs, they'll be displayed here, and any outputs are displayed below that. If they're active, they'll be lit up, and if they're not, they'll be grayed out. And for digital outputs, if you, for instance, wanted to do some troubleshooting and turn a point on or off, you can right-click on that point and toggle it from here. If you turn on cow gases, here it's just going to flow the gas, but it's not going to actually record any results. But yeah, finally sequences, and this one again is mostly used by our implementation engineers, but these sequences are what you're going to use to control the flow of gases while you're doing cal error or bias drift or whatever. But if you wanted to see the steps that go into the sequences, here's where you would do it. So our CalGas 0, for instance, has a 10-second cal purge lead. Then it turns on CalGas 1, cal select, fast cal for 30 seconds. And then it just flows CalGas 1 and cal select. So that's basically it for the configuration part of things. So we can go back to the main page and show you how to do a test. So in order to run a test, you would click this new reference method button, and it'll take you to a page here where you select a unit. Again, most of you will only have one unit, so this will be auto selected. You select which instruments you want to use for a test. You give the test a name or a description. And any reporting notes, these are totally optional. And one thing to note, there's only one tab here now, but once we create a test, there will be a second tab uh, called Create from Previous, where you can use any previous test that you've created as sort of a template for the new test. So you don't have to go through and set up the queue every time. But anyway, once you've set this all up, just click Start Test. And what we're doing here is we're going to build a queue for our test. But before we do that, let's go over a little bit about what's on this page. So at the top here, we have a test ID. And this is used in the spreadsheet so you know which test to pull. So just remember that number. It's also displayed on the main page where you view all the previously run tests. Over on the left-hand side here, we see the real-time readings of any instruments that we've selected for the test. And if we wanted to add calculations that I was mentioning earlier, you can right-click in here and go to Add Calculations. And let's add NOx rate. So you can see a real-time NOx rate reading while the test is underway. We have sequence control here. This is in case something goes wrong and you need to start or stop a sequence. You can select a list of sequences here and then start it or stop it. All the digital outputs that are set up for the system will be displayed here as well, and you can turn them on or off at any time. All the active outputs are displayed at the top, and any inactive outputs are at the bottom. In the middle here is our queue. Obviously it's empty because we haven't set anything up. We start the test in manual mode, which means every step you have to start and it'll end itself when it's finished. We have two different views here. This is the queue view, and we have a split view where we split up the QAs and the runs. And clicking this button will take you to the 1 minute averages for the runs, but since we haven't started any runs yet, this is empty. So the first thing we would do is let's add a QA. And that'll bring us to this wizard. And we'll start with a cal error. You have the option to do a post QA purge sequence. That means once the cal error is finished, it'll do a purge for whatever sequence you select and for whatever duration you select. I'm just going to skip that and we'll go to the next page. And here's where you select whatever bottle you want to use for step 1. We'll start with a 0. And also, when I was talking about the active and inactive bottles earlier, inactive bottles will not show up in this list, just the active bottles. So anyway, we'll start with a 0. Go next, and we want to say which sequence are we going to run for the 0. So we select a sequence, and we'll do our CalGas 1 0 sequence, and we select a duration here. Once we're done with that, click Next, and you have to tell it, is this a 0? This is a 0 for every instrument, but you may have a bottle that is, let's say, a 0 for NOx and SO2, but it might be a mid for CO2. So you would select mid there, but it's a 0 for all of them. So we'll just finish, and it starts adding our 0 step. Now, once we've started a cal error, it won't let you do anything else until the cal error is finished. And it considers a cal error to be finished once every instrument has a 0, a mid, and a high. So we'll go, let's see, let's use CalGas 2 here. Select our sequence. Oops. And we tell it that this is a mid for each one of our instruments. And we'll finish our cal error by selecting CalGas 5. and we'll tell it this is a high for all the instruments. And you'll notice that once we've selected 0 or a mid, it's removed as an option here. So the only other options here would be high and none. So if this bottle, for instance, wasn't used for CO2, we would say none. So now we've got our cal error finished. We can go back and add another QA. And now we have some other options here. We can go bias and drift, we can go converter efficiency, converter efficiency bag procedure, or response time. I'm just going to go with the bias and drift. And once you select a bias and drift, you can use a cal error step as sort of a template. So we'll just go with a 0 first. And we go next. And this will not prompt you to use a bottle because it's going to use the same bottle that you used for the cal error. But we do have a set values page here again. And the reason for that is for extractive RATAs. You would start the cal error doing a direct cal, I believe, and then for any subsequent bias and drifts, you would need to run it as a system cal. So if this was a cal, or if this was an extractive RATA, our first sequence for the cal error would be a direct cal sequence. So what we would do is remove that and then go back and we would find a system cal sequence. So again, this is a SIMS, so it doesn't have system or direct cal sequences, but we'll just pretend. So just click finish, and we'll add our bias and drift steps. And the same thing with the cal error. You can't select anything else until the bias and drift is finished. And the bias and drift is finished when every instrument has a 0 and either a mid or a high step. So we'll just use the mid step from the cal error. And just like before, you would add or remove any sequences if you need to. And now we can add a run. And when you add a run, it'll prompt you for the minutes that you want the run to go for. It defaults to 21 minutes. We're just going to change it to 2 minutes just for brevity. And there's a checkbox here for stratification. So if you check that, it's essentially just a run, but the spreadsheet will know that it's a stratification test if you check that box. So we'll just add our 2-minute run. And you're probably thinking this is very tedious if I want to go through and do 9 or 10 runs. But once you have a bias and drift check and a run created, you can right click in this grid and you can duplicate QA and runs. And you can tell it how many runs you want to create. Let's just go with 4. So click OK. And it will use this bias and drift and this run and just duplicate them. So now we have 4 more runs. And from here, you can start the test. So we'll just start this up. And once the test starts, the currently running test will sort of be displayed in this blue color. And you can see some real-time values over here on the right. Kind of see where we are. The CO2 currently would fail because we're reading too low, but the other ones would pass. And we have the step duration. So you can change this on the fly. So we can run this down if we need to. And if you get to a point where you're happy, you don't want to run this down, 100 seconds or so, you can just click accept values and it will immediately evaluate this QA step and go on to the next one if it's in automatic mode. If, for instance, something goes wrong and say your cal gas isn't flowing or whatever, you can abort this and it will pause the test, it'll stop the gas from flowing, and it'll reset this QA as if it never happened. So we're probably going to fail this, but I'm just going to accept values. So we can see that the NOx and SO2 passed, but CO2 did not. So it's displayed in red. And again, this is manual mode, so if we wanted to continue on anyway, we would have to click resume. But if you're not happy with this and you want to restart it, you can right click and go to reset QA step or reset QA sequence. In this case, they'll both do the same thing. But let's just resume. So this will start the next step in the sequence, which is the mid. And we don't actually have any cow gases set up, so these are all going to fail. But if we were to put this in manual mode, once this finishes, it's just going to keep going on to the next step. And once it finishes the cal error, it'll pause because we have a failed QA event. But if it didn't fail, it would just continue on with the bias and drift, and assuming all of those pass, it'll continue on with the run, and then the bias and drift, and it'll just keep going all on its own. But let's just accept values and move on to the next step, because I want to just display or want to demo a few things here. And we'll just accept values again. So these failed. We're not happy about that. If we just wanted to reset the high step, we could right click and reset QA step, and it'll wipe out the results of the high. If we wanted to undo the entire cal error, we could right click and reset QA sequence, and that'll get rid of the mid and zero instead of just the mid. So now we can just start it over. And there are some other options here as well. You can delete a single QA step or run. You can delete everything or anything that hasn't been performed. We've already demoed the duplicate QA and runs. If you forgot what bottle you used or you selected the wrong bottle when setting this up, you can right click and view edit step actions. And this will take you back to the step actions here. This is for the sequence, not the bottle, but say it's turning on the wrong IO, you can change out the sequence here and then just restart the cal error. If you selected the wrong bottle, you can change the bottle. It's important to note that that only works for cal error. So you can't go to a bias and drift and say, well, I want to use a different bottle than what we used for the cal error. It won't let you do that. You can move certain steps up or down. So once you've set this up, you might say, I want to do the high before the mid. So we can right click, move that up, and it'll move the high above the mid. And you can also move it back down. And as I mentioned in what's new, we can move entire steps up and down. So if I wanted to move this to back-to-back bias and drifts, for instance, we can move this QA up. So now we have two back-to-back bias and drifts, and then we have our run. And we can move it back down if we need to. Let's see. So this is sort of what the queue view looks like once you've started setting things up. Any results will be displayed here. There's a response time button here. So you click that and you enter in your response time. And it's important to note that you cannot start a run until you've entered a response time. You can do your cal error and you can do a bias and drift, but once we get to this run, it won't do it until the response time is entered. And it will wait until the minute or the top of the minute following 2 times the response time before it will allow you to do the run. So let's just start this back up. I'm just going to enter in a response time of 1 second just to make this quick. And it will give you a warning if it's less than 60 seconds. That's because some people might mistakenly believe that this is that you're entering minutes instead of seconds. So that's just a little warning there. So I'm just going to accept values here and we'll blow through this. Switch that to automatic. And you'll see a pause button here as well. While in automatic mode, if I were to pause this test, it would finish the current step and then just stop. So if I were in automatic mode and then doing the mid, I click pause, it'll finish this mid-level step, but it won't start the high until we resume it manually. But I don't want to do that. I'm just going to accept values. And since it's an automatic mode, it's just going to keep going. And even though it is an automatic mode, it didn't go on with the bias and drift, and that's because we have a failure. That's okay, we don't have any cal gas bottles. So I'm just going to click resume and let it start up the bias and drift. And just like with the cal error, you can abort or you can accept values and just move on. We're just going to accept the values and it'll move on to the next step. Okay, so we finished our bias and drift. We've entered in a response time. And now we have to wait to the top of the next minute following 2 times the response time. So our response time was 1 second. So those 2 seconds are up, but we need to wait until the top of the next minute. So that's 9:39, and this will tell you when the next run is scheduled to start. Trying to think if there's anything else I can talk about while we wait. Again, we can pause this and it will not start the run until we resume. There's a done button here. I would recommend that you do not click that until your test is finished, because once you click the done button, you cannot restart the test. Okay, so our run has started. And you can see on the right-hand side here, our run duration of 2 minutes. We've been running for 11, 12 seconds now. You can see the averages for the run. And you can stop the run, which means it will end it after this minute and just move on to the bias and drift. Or you can pause it. Now, when you pause a run, you have 2 options. You have the option to pause the test, which will mean the run will finish and it will pause it before beginning the bias and drift. Or you can pause the run itself, which means the current minute will finish and then pause the test, and then you can resume the run at a later time. But I'm not going to do any of that. We'll just let it go. And since we're in automatic mode, it's just going to keep going as long as everything passes. I'm going to pause the test, actually. So that's pretty much it for the product itself. I guess we can open it up for questions.
If you do have any questions, the questions panel is on the right-hand side of your screen. I'll give everyone a couple seconds if they want to throw in a question. Doesn't look like we have any questions right now, Andrew. Is there anything else you'd like to add before we end the webinar?
Let's see. We can go back to the main page here, and here's our test. You can continue it at any time, assuming it hasn't finished. And here's the create from previous that I was talking about earlier. So we could use our previous test as a template. That's how you do it. Yeah, I think that's it.
All right, sounds good. Well, if there's no more questions, it looks like we'll wrap up today. Thank you all for taking time out of your morning and joining us on this webinar. Thank you, Andrew.
Thank you.